All right, so today we're going to talk about the chain rule with trig functions. It's very similar to what we've already discussed. You just have to apply the chain rule and you're going to be encountering some trig functions along the way. So let's go ahead and do a couple of examples here. All right, so let's say I gave you y equals the sine of 2x. Now I'm going to take a moment and I'm going to rewrite this so we can sort of see what our inside and outside functions are when we talk about the chain rule. So our outside function, let me use white here, is the sine function. Okay, so our outside function is the sine function. And then our inside function is the 2x. So if we're going to use the chain rule to find the derivative, we have to take the derivative of the outer function. And this is when knowing and having your trig identities nearby is going to be really helpful. Or not your trig identities, your derivatives nearby is going to be really helpful. So if you know what the derivative of sine is, we know that's cosine by now. So the outside function, remember, is sine of x. So the derivative of that will be cosine of whatever's inside. And then the inside function is 2x, and the derivative of that is just 2. So if we're going to use the chain rule here, we take the derivative of the outer function, which will be cosine of something. In this case, that's 2x. And then we'll multiply that by the derivative of the inside function. So in this case, that's 2. So if we simplify this a little bit, our derivative just ends up being 2 times the cosine of 2x. Let's just do one or two more simpler ones, and then we'll try some more complex ones. So example 2. Let's say we have the function y equals cosine of x minus 1. Once again, I'm going to rewrite this so we can sort of see our inside and outside functions. Our outside function is the cosine function, and our inside function is x minus 1. So if we're going to apply the chain rule, then we need to find the derivative of the outer function, which if we think about it as this, we know the derivative of that is negative sine. And then the derivative of the inside function, which the derivative of x minus 1 is just 1. So when we put that all together, we have the derivative of the outer function, which is negative sine of whatever's inside. In this case, that's x minus 1, times the derivative of the outer function, which in this case is just 1. And then once again, just taking a moment to rewrite this so it's a little bit nicer, we have negative 1 times the sine of x minus 1. If you don't want to write the negative 1 and you just want to write negative sine of x minus 1, that is also okay. Okay, one more, maybe easier one, and then we'll get into more complicated ones. So let's see. Let's take y equals the tangent of 3x. And again, I'm going to rewrite that so we can see our outside function and our inside function. And knowing our chain rule, we have to be able to find the derivative of the outer function, which looking at our trig derivatives, we know that should be secant squared. And then the derivative of our inner function is just 3. So the derivative of tangent of 3x. We're going to take the derivative of the outer function, which is secant squared, and then we're going to write the 3x in there, times the derivative of the inner function, which we know is 3. And then again, just cleaning that up a little bit, we can see that's going to be 3 times secant squared of 3x. All right, so let's try this one. Again, I'm going to rewrite this so we have our outer and inner function sort of identified. So 3 tangent is our outer function, and then the inner function is just 4x. So using the chain rule, we'll take the derivative of the outer function. So the derivative of tangent is just secant squared. So that's going to be 3 times secant squared of 4x. And then we're going to multiply that by the derivative of 4x, which is just 4. And then let's just simplify that a little bit. 12 times secant squared of 4x. So that one wasn't too bad. Let's try another one here. So let's do this. F of theta equals 1/4 times sine squared of 2 theta. Now you might be noticing that it looks like there's actually kind of the possibility of having multiple kind of inside functions. So let me try rewriting it like this first. So sine of 2 theta, and the whole thing is squared. So we've really got 3 layers of functions this time. So let's use 3 different colors. So our first layer, that outside function, would be 1/4 of something squared. Now the next layer is the sine function. And then the final layer is the 2 theta. So there's actually 3 layers of trig function, or of kind of functions here. So how do we approach that? Well, we can do what we did with the chain rule. We just have to kind of make sure we get all of the inside functions, right? So we're going to start with the derivative of the outer function. Okay, so the derivative of the outer function, so we'll kind of go through this one function at a time here. Derivative of the outer function, let's think of that as 1/4 something squared. So the derivative of that, we'll bring the 2 down. That's going to be 1/2 times something raised to the first power. So I've got 1/2 times whatever's inside there. So I'm just going to rewrite everything inside just as is. Okay, raised to the first power. Now, we're going to multiply that by the derivative of the first inside function. So that first inside function is the sine function. So the derivative of the sine function we know is the cosine function. Okay, so I'm going to multiply this by the cosine function and the cosine of 2 theta. And then finally, I look at that last inner function, which we're saying is 2 theta. Now that's no different than if we were to write 2x. So the derivative of that is just 2. So I will multiply by 2. All right, and then let's just clean this up a little bit. So we've got this 1/2 and this 2 that we can multiply together to get 1. And then we have 1 times the sine of 2 theta times the cosine of 2 theta. And that is our final derivative. So that's what we would say is the derivative of f. So there could be many layers of functions, and then we just kind of keep finding the derivatives from the inside out. Let's try another one like that. Now this time, we have to pay attention to what's in parentheses, okay? So the 2x is the part that's being squared, not the sine function. So I could probably rewrite this, and I'm going to rewrite this as x to the 1/2 power plus 1/4 sine, and then I'm going to square the 2x. So we'll make that 4x squared, okay? So let's talk about how we find this derivative. Now we have 2 terms, so we're going to find each derivative independently. And I'm going to think about rewriting that sine function as the layers. So my first layer would be 1/4 sine, and then my inside layer is the 4x squared. Now there's no other like further layers there, so that's really all we have to think about. So let's find the derivative of each part independently and then put it all together. So we have the derivative of x to the 1/2 power. By now, I won't go through the long development of that, but by now you should know that that's going to be, you can either write it as 1 over x to the 1/2 power, or you could write it as 1 over the square root of x, whichever one you prefer. Doesn't matter. Second part of this, we're going to have to find the derivative of that second term using the chain rule. So we look at the fact that we have 1/4 sine as our outer function and 4x squared as our inner function. So the derivative of that outer function is just going to be 1/4 cosine. And then the derivative of our inner function will just be 8x. So when we go to put that all together, we're going to have, let's see if I can leave that so we can see it, plus, so we'll have the derivative of the outer function, which is 1/4 cosine of 4x squared. Then we'll multiply that by the derivative of the inside function, which is 8x. And then we can simplify that a little bit. So the 1/4 and the 8x we can multiply together to get 2x times the cosine of 4x squared. And I apologize, you guys are probably yelling at me in your heads right now. That should have a 2 in front of it when we find the derivative. All right, I'm going to do one more where we see the repeated kind of chain rule happening. And then if you feel comfortable, you can go ahead and start the Go Formative if you don't need to see this video. It's here, though, if you need it. So let's do one more. So let's say we have f of t equals sine cubed of 4t. Okay, so again, we have to think about the fact that this is sine that's being cubed and not the 4t that's being cubed. So if I were to rewrite this, I would rewrite it as sine of 4t all cubed. So let's kind of decipher what our functions are. Okay, so we've got the outermost function, which is that thing being cubed. And then the next outer function would be the sine function. And then the innermost function is 4t. So just kind of taking it apart and looking at it like that. Now let's do the derivative. So the derivative of f of t, we have to use the chain rule. So the first thing I'm going to do is I'm going to think about, let me move this over a little bit here. Let's think about the derivative of something cubed. Well, that's going to be 3 times that thing squared. And then we have to think about the derivative of sine of something. And by now, I hope that you know that that's just the cosine of that thing. And then finally, our innermost function is 4t, and we know the derivative of that is 4. So putting that all together, let's find f prime of t. I'm going to move this over just a little bit more to give myself some more room. So f prime of t. Okay, so the derivative of the outer function. So that's what we have in pink here. That's going to be the 3 times that thing squared. Now that thing is sine of 4t. All right, then we multiply by the next step inside, which is the sine function, the derivative of that. So the cosine would be the derivative of the sine function, and that's the cosine of 4t. And then finally we multiply by the derivative of the innermost function. So the derivative of 4t is just 4. And then it's just a matter of simplifying. So since this is one big multiplication problem, you know, we can multiply the 3 and the 4 together. So I would have f prime of t is 12 times the sine, and I'll write this with the parentheses around it. Well, we could write it either way. So I could write it, this is kind of the more proper way to write that, sine squared of 4t times the cosine of 4t. That would be the better way to write this. I don't even need that multiplication symbol here. If you like it, you can write it, but in Go Formative, it's a little tough to put that in. If you wrote it with the squared on the outside of the sine function, like I did in the step above here, you know, that's not wrong. This is just, if you're talking about, you know, more proper notation, that's what it would look like. Okay, that should help you with tonight's assignment. So go ahead and get logged on to Go Formative and you can start working. There are going to be some problems where you're going to have to find the derivative at a specific point. I think you guys have done that enough that you should be comfortable with that. Just plug in the x value after you find the derivative and evaluate. And I'm also going to ask you to write the equation of a tangent line for a couple of functions. So just remember your process for writing the equation of a tangent line. You can go back and look at some of your old notes if you get stuck on any of that. Okay, I will see you soon. Good luck, and go ahead and get started on the Go Formative.